Alright, so this week, we're going to do another practical on 3D flow, which is this one. Practical Lab 2, Car Spoiler Design and Optimization. So let's check it out. Open up the worksheet. And let's find out what we're supposed to do this week. So it's about a car spoiler design. We would like to properly design a spoiler to be used in a high performance car. We want to determine CL and CD of the spoiler at variable angle of attack, and maybe we want to improve the design of the spoiler. So this was the sports car which was chosen, and we are creating our own spoiler at the back, and the dimension is about 2 meter width, and the length is about 0.75. So the chord would be 0.75. The width would be, the span would be 2 meter. You can select typical airfoil designs in airfoil tools. You can Google this up, airfoil tools, and we can generate coordinates by using the generator NACA 2412, for example. This is a code which was chosen. You can choose your own configurations. So let's go and check it out. Let's go to airfoil tools. Click here. You're going to see something like this. You can go to symmetrical airfoils, or you can just select NACA 4-digit airfoils. So we're going to choose this one, NACA 4-digit airfoils. These are some of the databases available. Let's look for generator. This one, is there a generator here? NACA 4-digit generator. Over here are some databases only lah. 2414. You can select that file for the coordinates and all this. But let's do it on our own. NACA 4-digit generator. So currently I have 2412 airfoils. I can change the maximum camber percentage from 0 to 9.5. For example, if I change to 7%, and I click enter, the maximum camber has changed. If I put I don't know, 9, let's plot it. It has changed some more. I can also change maximum camber position from 0 until 90%. If I change to 80, what happens? Will be too much. 30 is good. Or 40. Okay, so 45. Yeah, doesn't matter much. And I've got my thickness here, 12% here. If I were to change it to make it thicker, for example, 40, this would be very thick. Yeah, my F1 has become very thick. I can change this. Oh, no, thickness is 30, only limited. Maybe I want to do 10. A thin one. 20 is good. No, 15. 15. Okay, 10 lah. 10 is good. And then I've got my number of points. Number of points currently is 81. I can change those to more lah. For example, I want 100 points. There you go. So I've got my airfoil now. My airfoil now is NACA 9410. These are the configurations, and I have my dat file here. Dat file will be my data file up until 100 points. Can I send this endpoint to a plotter? I can do that probably, but I just have to copy actually. Select here and copy everything. Control C. Now let's open up a Microsoft Excel worksheet. Can I just copy paste here? Right click and paste. It would not be so good, right? Because my data will be all in one column. So this is not a proper way for you to import raw data into Excel. What else can I do? Right click. No, I can't do this. So in order to do this, I need to create a text file, which is text document, and paste everything here. So this is my raw data. So the whole raw data is here. I'm gonna file, save as, NACA 9412. So this is my NACA 9412. And then if I go back to my Excel, I can click data, and from text, and I'm gonna search desktop NACA 9412 import. So it's properly arranged lah, into column 2 and column 3. Everything is properly separated. So I'm gonna click load. So I have my data now lah. Column 2 and column 3. How many data do I have? It should be 100 lah. 100 points. So from this particular data, you can highlight only 2 columns. Highlight 2 columns. And then click on insert, and then go to here, chart. Scatter chart XY. I can click this one, or I can click the other one lah. The other one is smooth lines. So choose the smooth lines. So this was my airfoil, which has been created using only coordinates. So it doesn't look like it because the aspect ratio is not right. I gotta do maybe something like this in order for it to be aspect ratio correct. So this is my airfoils. And if you take a look at it, the airfoil, the length of the airfoil is only 0 to 1, so about 1 meter only. However, your car, the length is about 0.75, the chord. So 0.75, I gotta do some changes to it. If you look at the data, column 2 would be your X. Column 3 would be your Y. Column 1 is nothing. I can delete it. Click here and then right click and then delete. I can highlight these two and I can put it at the center. So it's like that. I've got X and Y. Why is X here? Really? Or maybe this is Y. Oh no, this is correct. This is X. Because this is in the X direction, right? The maximum direction would be 1. So 1 all the way down. Yeah, until 1 again. So X, I need to do changes. I need to do X is actually equals to 0.75. Okay, highlight this one, put it at the center. I want to change I want to transform this data. Why is this data 0 to 1? Because it's only giving you the aspect ratio . So since I want to scale the data to smaller, I am scaling it to 0.75, and also Y is equivalent to 0.75 also. Center. So this is the two thing lah. So I can click this one, put some borders there. If I want to, I can right click here, right click, insert. I can click here and insert. So I have a proper border like that. I can highlight these two and then put some color. I can put some borders also if I want to. Depends on you, right? You want to make your data beautiful. I like. So now I'm going to do the transformation lah. I'm going to click the cell. So bear in mind, it has to be on the same adjacent cell. Click this one and click equals. Highlight the cell I want to transform. This cell. I click multiply, which is asterisk 0.75. I'm going to click enter. And then I'm going to go to the corner there. There's a dot there, and I'm going to double click. If nothing happens, then you have to highlight there and drag all the way down. All the way down, it's going to transform. Okay, there you go. So the maximum distance has been changed from 1 to 0.75. Why? Because we multiply by 0.75. So let's do the same thing on the next cell. Equals y multiply 0.75. Enter. Click here. Go to here and then double click. Double click. It's going to highlight all the way down, down, down. Okay. So you can create another another chart again, another graph again. If you click this chart, it's going to highlight the old data. You can just click here, Control C, and then click here and then Control V. You can copy paste. However, this data will be referencing the old cells. What you can do is you can just drag. Can you drag it? No, click this one. Can you drag this thing? Yeah, you can drag it. And then I can drag this one. I cannot drag it. I can't. So might as well delete. Try again. Normally it works. Click Control and then drag. Again, go right click. Select data. Y is currently there. Click this one. Y is here. Enter. No, it doesn't work. Chart data range. I think I just highlight both. Maybe it works. Enter. Then click OK. Does it work? Yeah, it works. Because now everything has been referenced to a new data. This one highlights old data. Click the new one, highlights new data. So the distance has been changed also. 0 until 0.75. So I've got a new airfoil lah. This is actually longer This is not up to scale 0 up until 0.75 maximum. Probably there. 0.8. Yeah, it's like this. 0.8. This one also I got it smaller it a bit, right? 0.75. So you can see old data you have reference to old one, new data is referencing to new one. However, I have another problem lah. And the problem is this is an airfoil, and if I were to put this in a wind tunnel, most likely it's gonna fly. So you want your car not to fly, you want it to have downforce. So you need to inverse the direction. So what you can do is, this is your X data, this is your Y data. You need to inverse the direction. So you are inversing it in the Y direction. So your X data will be the same lah. Right click, copy. Can I paste here? Right click and paste. Yeah, I can paste this here. All the data has been pasted. What did I do? I click the top one, right click, copy, and I click here top, right click, paste. So everything is okay. X data is the same. However, Y data, it's new lah. Y, you have to multiply it by -1. Y equals multiply -1. Why do we do that? Because we wanna inverse the direction. Kind of looks like that. So if I click equals here, equals, referencing to the old cell, and then multiply by -1, and then click enter, I'm gonna get a negative. So go here and then double click at the bottom. So a new set of data has been populated. Everything has been in negatives. I am inversing the data only. Okay, so this is negative. So this is referencing an old cell. I can go here, right click, copy, go here, right click, paste. Okay, so I've got my old chart referencing old data. Let's do the same process. Right click, select data at the top here, click this button and then highlight new data. And then click enter and then click OK. So what happens now, this one is referencing to a new cell and the direction has been inversed. So if you notice what we're doing with all these coordinates, it's actually generating computer graphics. We are manipulating coordinates in X and Y and creating graphics. This is what's actually happening in your CAD system. Only thing is only behaving it in 2D lah. So next thing we need to do is we need to export all this data into SolidWorks. In order to export, you need another coordinate lah, which is Z. SolidWorks requires you to export data in 3D. So it requires another data in Z direction, and Z direction is everything 0. 0. So highlight the two things and then double click here. The whole thing will follow the trend. The trend is 0. Put it at the center. So this is the data that you want, X, Y, Z. Remember, when you want to export to SolidWorks, you have to, again, put it in Notepad. So you highlight. Don't highlight the top one. Don't highlight the top one. Highlight the data you want only. You got 100 points there. Control C. Put it in a new text document. Paste it. Everything is in 3D. Don't mind the spacing in your mind. Just leave it there. Just click File, Save As. NACA 9412 SolidWorks. So I've got this data, NACA 9412 SolidWorks. And now you can go to your SolidWorks. And import the whole thing. So just go to File, New, create a new part, click OK. And then you can select a plane. For example, if it goes to flow simulation, I always go back to features. This is where you do your CAD. Select a plane, for example, a front plane, and then click insert, and then click curve through XYZ. Now it's asking you the coordinates. Click browse, go to your desktop. You can't see anything because it's asking solid curve files. Change to text files. You can choose this one with all the coordinates. It's going to populate. However, I've done a mistake here. Everything is in millimeter, so this is wrong lah. I gotta change this. Cancel, go to here and then change to meter. Again, let's do the same process. Front plane, insert, curve through XYZ points, browse, change it to text, NACA, and then you're gonna see all this lah. The data is fine. Everything here seems 0, right? But this one is fine. And then click OK. So you're gonna see the whole thing lah. So the whole profile has been imported. And then you can sketch using this curve. In order to do that, you click on a front plane, a suitable plane that you can sketch. You can't do it on the top plane. You can't do it on the right plane. You have to do it on the front plane, the plane where your curve is. So this plane is this is where it is. So right click, click sketch. Now I'm going to use the curve as your sketch. I'm going to use convert entities and then click the curve and then click OK. Everything has been turned into black, so this is a proper sketch. If you look at the end, there's an opening here. I need you to cover it up. Line here to here, and then click escape and then exit sketch. So what you can do now, I've got a sketch here, sketch, and then I can extrude. How much should I extrude? I should extrude it by 2 meter. So this is your spoiler. Click on OK. So you've got a spoiler lah. The spoiler has been designed using exactly this one. Oh, 9410. So the data is actually 9410. NACA 9410. We have flipped it. Why? Because we want to use it in a car. You want to generate downforce instead of lift. Or we want to generate negative lift. So next thing you can do, you can go to flow simulation. Click on wizard. Save it. File, save as NACA 9410. It's actually 9410. Okay, everything has been saved. Click on wizard. Click on next. SI is okay. Click on next. This is an external flow. The direction is X. Click next. I've got gases. Double click on air. Air has been entered. Click next. This is okay. Next. And then I've got a flow in the direction of X. So X direction. So let's say this car is traveling at about 150 km per hour. So you gotta divide by 3.6 lah. 50 km per hour. Convert to meter per second. Divide by 3.6. And then click enter. The speed is about this much, 41.666 meter per second. There's a vector here showing the direction of the flow, and then click finish. And then you've got your computational domain. So this computational domain, you have to change it a bit. Let's look from the side. Computational domain, I gotta lengthen the area where you have your drag. So I'm not sure what's gonna happen here. whether it's going to create lift or whether it's going to create downforce. If it were to create lift, I have to angle it up a bit more. This looks like it's going to create a bit of a lift. Unless if I rotate a bit. But for the purpose of this practical lab, let's just go with it. Whether it creates lift or not, you can change as an aerodynamics engineer. Change the angle. Change the angle of your spoiler. Currently, it's being tested at 0 first. So let's test flow direction at 0. Computational domain, maybe this much. The front should be at least one length of your object. One length of your object. The rear should be about three times the length of your object. Okay. This length at the front, about one length. The rear is about 3 times. And the rest looks okay. The side view, a little closer, but never mind lah. This one is good enough. Okay. Next thing you need to do is you need to put in some goals. Right click on surface goals. You would like to know what is the force in the X direction and the force in the Y direction lah. X would be your drag, Y would be your lift lah. Whether it's going up or going down, let's see what happens lah. And then you need to select the surfaces lah. Click here and then click on your keyboard, click Control A, and then you've got all your surfaces selected, and then click OK. Next thing you need to do is right click and then click Global Mesh, and then I know this is going to be currently level 3, right? Maybe it's going to be too much. Let's try and find out. Click Create Mesh. I'm not running anything again. I'm just creating a mesh. I just want to see what kind of mesh I'm getting. Cannot be too long. If it's taking too long to generate, it's going to take too long to solve. It's going to create. It's taking too long. Yeah, we have about 889,000, close to 1 million cells already. This is totally not feasible for our computer, for our class. So we might want to tone it down a bit. Global mesh, right click again, edit definition, change this one to 1. From 3 change to 1, and then click OK. And then let's try to jam. Let's try to click mesh and then create mesh again. Unless you're doing final year projects, then that's a different story lah. Take your computational time much longer. That would be better lah for your final year projects. Is it done? Finished normally. I have about 78,000. This is okay, acceptable, less than 100K. So my mesh is okay. Can I view it? Right click, show basic mesh. This is the size of my mesh. Whether this thing is going to fly up or push down, I don't know yet. Let's see. I might need to tilt this spoiler angle currently at 0. What else should I do now? I don't have anything else. I only want to know what is the drag force and what is my lift force. And then I'm just going to click run. Solve new calculation, click run. I can watch the progress here. Click here. Insert goal table. No, click this one. Insert preview. front plane, is it? I don't know. Is it a front plane? Let's try. What can we see? It's a front plane. And then we just have to wait. Yeah, we just have to wait. Nothing else we can do. So what can we do in order to change our angle? If I were to change, currently my velocity is actually equivalent to, let's say if I were to put it at 50 meter per second, 50 meter per second. So this is currently at 0 angle. Let's say I put angle, and then there's a component called Vx, and there's a component called Vy lah. Currently the angle is 0. 0. I like everything, make it center. So currently Vx is actually 50 lah. Vy how much? 0. If I were to change it, oh, maybe I should put this one. Okay, this one is okay. If I were to change it, maybe 2.5 degrees 2.5, 5. So there's a trend here, 0, 2.5, 5. You can highlight the 3 trends and then drag it. It will follow up. For example, I can do up until 15. So you can imagine, probably I should draw a bit. So this is your, where is my pen? So currently the velocity is like that. This is pure Vx lah, which is 50 meter per second. So if it were to tilt a bit like that, so meaning I have changed this angle, change it like that. How much is this angle? Maybe 5 degrees. Let's say I wanna take this direction as positive lah. 5 degrees or 2.5. So the velocity has now been changed a bit lah along the direction of the flow. So now it no longer becomes like that lah. So it becomes, the Vx in your flow would be about, what, like that. Vx, this would be your Vy. So this would be your 5 degrees. So now Vx becomes Vx cos 5 degrees. So Vy becomes no, not Vx lah, V only lah. V sine 5 degrees. So you gotta convert it like that. The thing is with Excel, the angle currently is in degrees. Angle, degrees. Excel doesn't understand degrees. You need to right click here, insert. Angle is no longer degrees. It has to be in radian. Why? It's like that. Excel only can work with you using radian. Can we still see that one? Kind of. Yeah, you can still see it. So this one 0. Why? You gotta change it to radian. How do you change to radian? Pi is equivalent to 180 degrees. So what pi? Do it inversely. 180 degrees is actually 3.142 radian. It's actually like this. 180 degrees is actually pi radian. So convert lah. 2.5 to how much? So if it's 2.5 degrees, becomes x lah. How do you convert? Multiply. So 180x is equivalent to 2.5 pi. So x becomes 2.5 divided by 180 times pi. This would be your formula. So you gotta put in a formula here. Click equals. What is your angle? Angle is currently 0 lah. 0 divide by 180. Put a bracket there. And then multiply. Multiply. Use asterisk. So pi in Excel is like this. Pi, there's a bracket there. Why is it like that? Pi. Oh, can I put pi there? Oh, cannot, right? It's like this. Pi is like that. You cannot put pi only, no. You have to put pi and like that. And then click enter. So now the formula returns at 0. If I were to drag down next one, it will be like that lah. So 15 degrees is actually 0.261 radian. Then you can do lah. Vx. So this one, I can put the values here. Vx is actually equal to 50 multiplied by cos 0, enter. Vy is equivalent to 50 multiplied by, I don't need to put a multiply, I just put cos. Really, let's try. Cos, this one, enter. No, there's a problem. I gotta put asterisk here. Enter. No, it's not cos, it's actually sine. Sine. Yeah, now it becomes 0. So this is the formula lah. 50 cos m3. Click this one and then you drag it down. You're gonna see the values lah. Vy, drag it down, and then you're gonna see the values. So currently we're doing 50 and Vy is 0. If you want to do 5 degrees, for example this one, you gotta key in these two values lah. Where do you key in these two values? You key in the two values in your initial condition. Let's say I want to tilt it 5 degrees. And later if I want to tilt it 10 degrees, becomes like this. If I were to tilt it 15, it's going to be like this. So you got to plug it in your initial conditions. Why I do this? I suspect my airfoil is going to have a problem with downforce. It's going to generate lift. Let's see what happens. So let's go to your solver. Solver is finished. And then you can turn this off. X. Go to results. Go to flow trajectories, right click, insert, and then I'm going to click Control A, and then it's collecting all the edges. I'm going to click surfaces also. 1 surface, 2 surface, and 3 surface. So this one I'm going to change this to arrow. Pressure is fine. This one I can change to 100. And then I'm going to click OK. So I've got 100 points on my airfoil, and then I can probably play and look at the result. What's happening? I've got 2D flow at the center, right? 2D flow, and I've got a 3D flow at the edge here. You can clearly see the vortices at the edge. At the edge of the airfoil, these are vortices rotating. This is what this is observed in airfoils. If you go further, airfoils will have all this something called vortex drag at the end of your airfoils. So if you were to do a proper one like this, 0, 5 until 30 degrees, you can find out. And of course, if you are an aerodynamics engineer, you set this according to your track. Which track corresponds to which spoiler design. So the most important thing is for me to determine my cut plot, insert. I want to look at probably change to velocity. Where should I watch it? This should not be phase. This should be my front plane. And then I can drag it a bit, put it at the center. Currently it's there. I can drag it at the center. And I can preview. Okay. So this is, of course I can turn off this light. Make it brighter a bit. Am I getting higher velocity at the bottom? What is my velocity at the bottom? I can probe, right? Probe using this one. About 50 millimeter per 50. 50, 49 something. At the top, around 24. So higher velocity at the bottom, meaning lower pressure. Yeah, I think I'm getting downforce. At the top, there's a lower velocity, meaning higher pressure. I think I'm okay. I'm getting downforce. Again, other things you can do, you can create a surface plot, right click, insert, click on the surface that you want to see. This one probably. You might want to look at pressure here, click on OK. It highlights area where you have high pressure and low pressure. See, low pressure at the bottom. I might be okay. I can hide the cut plot just now. And then what can I do now? I can look at goal plots. Right click, insert. I'm looking at X and Y. I can click show. It will show you the forces generated. Why am I getting very low? 6 Newton. This is quite low. But X and Y, 6 Newton only. What did I do wrong? Input data, go to project, general setting. Initial condition is 41 meter per second. This is okay. Goal plot, edit definition, click show. Currently, it's a very low. But then X direction, Oh, because I am getting friction forces here. This is wrong lah. That's why it's very low, because I'm just calculating friction force, not normal force. So I gotta run again. This is friction force, huh? So right click, delete, click yes, yes, delete. One more time I have to do. Right click goal, insert surface goal. Make sure you select the correct one. I selected friction force wrong. I should just check normal force and normal force Y. Normal force X, normal force Y. And then highlight all the surfaces. Then I'm gonna be okay. So this one is correct. SG normal force, SG normal force Y. No choice, I gotta run it again. Click run and click run again. So we have time to go back here, 0 until 15. Maybe we don't need to do up until 2.5 lah. This is too much. Change this one. No fill 5, 10, 15, 20, 25, 30. Maybe lah, depends on how you want to do it lah. This is optional lah. As long as you can do one analysis is good enough. These are the data that you need to key in on your own lah. If you want to change angle. Key in at the Vx and Vy at the initial condition. If you want to change the angle of attack. It's a long time, see? If you want to check the progress, you can click here and look at the results. What's actually happening? The result has almost stabilized actually. See, nothing is changing anymore. Normal X 97 something, the result has stabilized. And then normal y, 500 something, the result has stabilized. It's not going to change anything anymore. It's actually, you can stop it actually. So how do you check this one? You can click this one. Goal plots, click all, click OK. No, it's not going to change. If you wait until iteration 500 also, it's going to be almost the same results. If you get something like this, you can always stop it. The calculation will be stopped. Do you want to save the result? Of course, click yes. Solver is finished. And then I can go back to goal plot lah. Goal plot, edit definition. Now I have normal force. Click everything. Click show. I have about 96 drag force, 514 down force, right? Because it's negative. Click export to Excel if you want to see it in detail. Yeah, there you go. These are my results. For every 100 Newton of drag, I have about 500 Newton of down force. That is how much I'm getting. Again, if I want to change the angle of attack, I got to go to input data, general setting, go to initial and ambient condition. This is the thing that you need to do. Where can we see this? Should I print screen this thing? And then put it here. So you got to change. For example, if I want to do 30, right? 30 degrees. So I got to change Vx lah. Vx. Again, this one is actually at 41, right? So if it's pure, just now we were doing 50, right? So you know what I meant. If you follow my lecture, this is at v equal to 50 meter per second. Theta, we don't call it theta, we call it alpha actually, angle of attack. At alpha at 30 degrees, Vx would be 43.3 and Vy would be, that is a lot, 25. Why is it like that? Because of Vx, V cos theta, Vy, V sine theta. Is it correct? Let's say if you were to do it 30, right? So 50 cos 30 degrees. You're going to get Vx. And then Vy is 50 sine 30 degrees. Okay? You don't have to rotate the airfoil physically. You just have to change this velocity in x and y direction. That is one way to do it. There's another way to do it. It involves you creating something called, go to project, click on new parametric study. You can always do this one also. Click on a simulation parameter. You can change in general setting, initial and ambient condition. For example, you want to study velocity in x and y, and then click on OK. Currently it's 41.667, right? Currently lah. Let's say if you want to change this one to 50, can kah? Velocity in x. Can you put more value here? Right click. 50. Can I highlight this one? Control C, Control V. See? Everything has been put to you. I've got a few data here, and then in the y direction, you can highlight the whole thing, 0 until 25. Control C. Click here, Control V. Yeah, I've got the whole thing. So we run everything according to these values. And current value 41. You know what I mean. So this is the parameter. Output parameter, click on the button to add a goal or result feature. Click on a button, click this one. You want to study X and Y, click on OK. Input variables are this. You change the velocity. Output parameters are here, and then scenarios. This all will be generated once you click run. So these are the results that you'll be getting. So it's helping you. 50, 0, how much? 50. This is too much, This is too much. So many scenarios. So many design points. This cannot be done. Can but it's gonna take too long. How do you change, Then gotta change it a bit, This is taking too long. See, 50, 50. Oh, this is taking too long. Might as well change angle here. But the point is, things like this exist. If you change properly your input variables. How do I change this thing, Might as well change the angle. If I want to change the angle, I gotta go to feature and then create assembly from part and then tilt it from the angle there. You can do that also, but it's fine, So the one thing that I need you guys to do is just at least do one analysis and make it work. These are all extra parametric studies are all extra. I want you guys to get this to work. Animation, what happens? Nothing. Same thing. Stop. Flow trajectories. X this one. Flow trajectories. Edit. You can make your arrows slightly bigger a bit. Tang tang. Click OK and then play. I just want you guys to be able to do this, and of course I need you guys to have goal plot Click your goal plot, click show. I need you guys to have downforce, not upforce or negative lift. So up to here only. Parametric study you can explore. The moment if I click scenario, I click run, it will run the whole scenario. It's gonna be exhausting scenario. Oh, I can delete this point. 0. Oh, I got an idea. I've got an idea. You don't have to do so much. Right click, delete. Delete design point. Delete design point. Highlight the whole thing. Delete. Why do I need to do the whole thing, right? This is too much design point. I need about 5 design points only. See? I gotta clear this thing. And put these values How many? 3, 6, 7. 3, 6. Create. How do I create design point? Remove input variable. Alamak, wrong. Remove input variable. Output parameter, input variables. Click a button. Create X and Y. Click OK. This is where you put the variables. You get what I mean, right? This is optional. It will create too many scenario. This is good enough. You modify this individually. You only need 3, 6, 7. 7 design points. This one you can remove. You gotta change this one. 50. This one is okay. This one 0. Change to this one. How much is it? How much is it? 4 point. Control C. See, there you go. And then 8.6. Come on, I didn't copy. Copy. Optional, This is optional. 8.6 okay. And then I've got 12.941. And then I've got 17.101. And then finally I've got 21.1. Finally I've got 25. Click here, 25. There you go. So I've got all these data points. I can just click run. It will run automatically for me. But maybe my input data in terms of project, I don't want it to solve too long. Result. Goal lah. Input data, general setting. I don't want it to solve too long. It's gonna take time. Calculation control option. Then this is the one. Refinement, resolving, finishing. Goals convergence. Criteria to stop. One satisfied all goals. Goal convergence. Iterations. 100 It has stabilized at around 100 Yeah, at 100 already stabilized. At 100 already stabilized. So I can change this one to actually 100 Now if I were to click run and wait maybe half an hour, it will generate everything for me and I can create this graph. I don't have to do one by one by one. No, it will automatically do for me. Let's check it out. Later I'll truncate the video, make it shorter. All right, I'll be back.
Dia pun dua orang. Pagi kat Iza, Tang, siap dia. Oh, dia tak masuk tu. Dia Tang tak nak dia nak pakai Tang. Dua orang kena nak dia.
Here you go, I've got 1 point done. 130 drag force, and I've got a down force of 731. I gotta wait a long time.